most of the math that nurses need to do is simply unit conversions. Now, I'm going to teach you dimensional analysis, or sometimes people call it the unit factor method, as a way to do these unit conversions. The research shows that this method's really effective for most students, and I've found in my own experience that it's easier than memorizing a bunch of formulas. It seems to stick with students, and in the end, they actually have a really strong understanding of the dosages, the unit conversions, the weight differences that they're actually calculating that help them in the end to be better nurses. So, for example, I have here an order listed as to give 100 milligrams of metoprolol by mouth at 9 a.m. Now, I'm focusing in on this 100 milligrams. A lot of your orders for nursing patients are given in the metric system. They're given in milligrams, they're given in micrograms. Sometimes we even have milliliters per hour for your IV, or micrograms per kilogram per minute for those advanced calculations for drips and things like that. So we're going to start at the basics here. We're starting with this example of 100 milligrams. Now, you can't give your patient 100 milligrams and measure that out perfectly on a little scale. What you need to know is how many milliliters is this if it's a liquid? How many tablets is it? Or maybe they're capsules. How am I going to give this to this patient? So you're converting from something like milligrams, something in the metric system here, to something that's a liquid or a tablet so that you can measure it out and give it to your patient at the bedside. Another example of a unit conversion, one that we'll do today, is going from pounds to kilograms. Now, we're not changing our patient's weight when we do this. They still weigh the same. They're still the same patient standing on that scale. We're just talking about their weight differently. The heaviness that they are or aren't, it's the same. They weigh so many pounds or they weigh so many kilograms. We're just talking about those things in different ways. So let's do an example, and we'll use dimensional analysis to do this. If a patient weighs 180 pounds on the scale, how many kilograms does the patient weigh? So we need to first know some basic information, and that is how many pounds are in 1 kilogram. Now, we know you have to memorize, or you can obtain it from a resource, that 2.2 pounds equals 1 kilogram. Okay, that's what we would call your conversion factor, and you have to know that before you start. If you had a weight at the gym, just imagine you're working out and you're lifting, doing little dumbbell curls. This dumbbell weighs 1 kilogram. Maybe it also, on the other side of it, says it weighs 2.2 pounds. That'd be a little workout. And it would feel the same. The weight is the same heaviness, but we're talking about it two different ways. We can talk about it in pounds, or we can talk about it in kilograms. And we can think about that when we think about our patient. So this patient we know weighs 180 pounds. I always label the numbers that I'm using so that I'm clear about what I'm talking about. And when you get to more advanced calculations, this usually really helps you keep everything clear. So 180 pounds. When I use dimensional analysis to find my final answer, I use some basic math principles. We know that anytime we take a number and we multiply it times 1, it's equal to the same thing, right? 180 pounds times 1, 180 pounds. If I took 180 pounds and I multiplied it times 1 over 1, it's still 180 pounds. If I take 180 pounds and I divide it by 1, it's still 180 pounds. So we use this knowledge to help us as we do dimensional analysis. We see here that 2.2 pounds equals 1 kilogram. That's our conversion factor. And we can actually use that in a fraction format to convert from 180 to however many kilograms we need. So you take 180 pounds and you multiply it by your conversion factor. I know that 1 kilogram is equal to 2.2 pounds. So even though I'm talking about the weight with different terms, pounds and kilograms, it's still equal to 1. This here is my conversion factor. It's still equal to 1. When you're using a conversion factor, the top of the fraction and the bottom of the fraction should be equal to the same thing. In this case, we can think of our little dumbbell up here. It's still the same thing. It's still one thing. It's either 1 kilogram or 2.2 pounds. The other thing to consider with conversion factors is that you always need the unit that is on the numerator over on this side to be on the denominator on this side. This allows that numerator and denominator to cancel out. So we have pounds here canceling out the pounds there, and that's going to give us the kilograms in our final answer. So let's do this calculation on the calculator. We have 180 pounds times 1. That's 180. Then we need to go and divide it by the 2.2 pounds. I get 81.8 if I round to the 10th on my calculator, and I know that's 81.8 kilograms. So I've simply converted from my pounds to my kilograms now, and this is my final answer, 81.8. The awesome thing about dimensional analysis is that you can add on to this and do multiple conversion factors in the same equation. I'll explain these more in my other videos. If you were like, oh, I could simply just take my pounds and divide it by 2.2. A lot of you that maybe work in practice already do that, and that's fine. That's the kind of shortcut way. But dimensional analysis gives you the framework for why these formulas work. And if you ever forget the formula, or you forget, oh, do I multiply or do I divide by 2.2? You can write it out long form this way to double check your work. So keep using dimensional analysis, see if it works for you, and watch my other videos if you want to practice more and get an idea of how to use it in your dosage calculations.